So we're now on record, and we're looking at question number 1. It's a multiple choice question, similar to something that you're going to see on either on the midterm or the final. These are the type of questions they actually have come from previous midterms and finals. So the first question says, write the equation of a line that's perpendicular to y equals negative 4x plus 1. So we're talking about the equation of the line is y equals negative 4x plus 1. And we want a line that's going to be perpendicular to it and passing through the point negative 4, 4. So if we recall, in order for two lines to be perpendicular, the slopes have to be opposite reciprocals. And we said that whenever we want to write the equation of a line, the first thing we're going to actually look for is its slope. So since this was the original line that they gave me the equation of, and asked me to find a line that's going to be perpendicular to it, this line is in the y equals mx plus b form. So this line, the number in front of the x, the coefficient of the x, is the slope. So my original line slope is negative 4, which really means it's negative 4 over 1. We want a line that's going to be perpendicular to this. So what must its slope be? The new slope, I'm going to do this in blue, is going to be, let's call this, the new slope is going to be, we're going to flip it over, we're doing the opposite reciprocals, and we're going to change its sign. This one was negative, that means this one is going to be positive. This is my new slope. My new slope has to be positive 1 over 4, because it has to be the reciprocal. Remember, if there's no number underneath, if it's not a fraction, just put it over 1 to make it into a fraction. So a question? Okay. So before we do anything else, let's check the answers. Sometimes multiple choice questions are easier. Sometimes they're harder. How are they easier? Because you can check the answers and sometimes eliminate some of the choices. How are they harder? Because sometimes you might get an answer in one format, which would be correct, but that format doesn't come out as one of the answers, and you have to be able to get it into the format that the answer is given. So, but let's look at each answer and see what the slope of each line is. So in answer A, the slope is negative 1/4. But that's not what we wanted. We wanted the slope to be positive 1/4. In B, the slope is 1/4. So this is a possibility. But maybe there are other possibilities. Let's keep going through the answers. In choice C, the slope is negative 4. That's not what we want. We want that if they ask for a parallel line, yes, we would want a slope of negative 4. But perpendicular, it has to be the opposite reciprocal. And choice D is negative 1/4 slope, which again is not right. The only one that had the right slope happened to be choice B. I really should have figured out the rest of this question. I should have done the algebra to figure out if that point is on the line. But I don't even have to. I can save myself time because the only possible answer that makes sense is choice B. And yes, Tahira, you were 100% correct. Thank you. Thank you. Getting credit for that. Okay. So a few people signed on since then. I'm going to give you a couple more minutes to try number 2. Again, this is a multiple choice question. So you look at the answers and see what makes sense. Again, you can only do this with multiple choice questions to see, don't just look at the question, look at the question in the context of its answers, because sometimes that can be a help. Again, if you put an answer on the chat, then you get extra credit for doing that. And it's going down right on my sheet of paper. Okay, thank you, Kiana. Okay, so 3 people have sent me and 3 people have gotten extra credits. We're going to see who has the correct answer. Okay, so I'm going to need a little bit more space. So is it all right if I erase that top question?
Yes.
Okay. And Tahira, thank you again. So this is the one we're going to have to remember how to solve. It's called an absolute value equation. This is a review of a topic that we did in chapter 1. And I'm going to remind you that the first thing you have to do when you have an absolute value equations, which you will recognize with these 2 lines on either side of the algebraic expression, you're going to need to first make sure that you have the absolute value all by itself, which we do. There's nothing on the outside of it that we have to bring to the other sides. That's check number 1. And the next thing you have to check is that once you have the absolute value all by itself, when you have the absolute value isolated, you want to check the number on the other side of the equal sign. It has to be a positive number. If this would have been a -3, I would have stopped right there and said there's no solution. But since this is a +3, it means we can have 2 solutions. we have to have two solutions. We solve this by taking the equation 1/3 x minus 8 and making it +3. That's one equation. The second equation you get by doing the same exact thing, 1/3 x minus 8, but equaling to -3. Either the inside can equal the positive number over here or the negative. You have to change this thing into two equations, and you have to solve them. And how many solutions are you going to get? Obviously two, which means if I look at my, let's say I forgot totally how to do this. The only thing I remembered is that I was supposed to get two solutions. There's only one choice here that has two solutions. So that must be the right choice. Choice B. If you only came up with one solution, even if that number is correct, it's not the total solution, so therefore it's not a correct answer. But since this is a review, let's see if this really works out. How do we solve this? Well, the first thing I'm going to do is take the first equation and add 8 to both sides. So I get the x by itself. I have 1/3 x equals 11. And this really means 11 over 1 if you think about it. So remember, when we have a fraction, we want to multiply by the reciprocal. And the reciprocal of 1/3 is 3. So we're going to multiply both sides by 3. I'm going to erase this because I have the question up here. And multiplying 3 times 1/3, that cancels out. I'm just left with x. And 3 times 11 is 33. In other words, or you could look at it, you're dividing by 1/3, which is equivalent to multiplying by 3. So one answer is 33. We do the same thing over here. We add 8 to both sides. And I get 1/3 x equals -3 plus 8 is +5, which I'm going to write as 5 over 1. And again, I'm going to multiply this whole thing by 3 over 1. And again, the 3 over 1 times the 1/3 just gives me the x. And the 3 over 1 times the 5 over 1 gives me 15. So my two answers happen to be 15 and 33. And that is what we came up with as choice B. Anybody who picked choice B with it was absolutely correct. If you only picked 15 or you only picked 33, you were partially right. But in a multiple choice question, partially right doesn't count. It is not correct. The only correct choice was choice B. Again, I'm going to be doing this on a sort of regular basis, trying to prepare you so that you're ready for the midterm in terms of the type of questions you're going to see on the midterm, and also to make sure that we keep reviewing things that we learned already, so that it isn't, when you get to study for the midterm, all the material should be fresh. Before I go on to what I wanted to say today, I just want to tell you about next week's schedule. Next week, there is no class on Monday. There are no classes at all on Monday. And Thursday has a Monday schedule, which means we are going to meet on Thursday instead of Monday. So next week, we don't meet on Monday, but we do meet Wednesday, Thursday, and Friday. We're going to have our regular 3 classes. It's just that the Monday classes, instead of Monday class, we're going to have Thursday class. Okay, let's just review the last thing that I talked about on Wednesday. And that was what we called functional notation. And how to use functional notation. So let's say I gave you this, f of x is equal to x minus 9 squared. And I ask you to find f of 4. While you're doing that, I'm going to start taking attendance. Again, if you get an answer, it would be good if you put it on the chat, because then you get, I'm keeping track of who's doing things on the chat. Even if you don't get it right, if you make an attempt, you get credit. Okay, Olivia. Isis,
Here.
good morning.
Good morning.
Alvaro. Louis,
Here.
good morning.
Good morning.
Emma.
Here.
Hi, good morning. Demetrius. Desmond. Shania. Shania Haley. Caden Harris. Caden. Kayla Harris.
Here.
Good morning. Sanjita Hussain. Sanjita. Oriana, I know you're here. Tahira, I know you're here. Michaela. Michaela Martinez. Kiana.
I'm here. Sorry. It was taking a long time for me to unmute.
Okay. Thank you. Kiana, I know you're here because I saw you answered the question. Truthfully, if it's quiet in your house and there's no background noise, you can certainly leave on your mics. I don't mind. It's just it becomes a problem if there's background noise. Carly. Are you here, Carly? Okay. Jenna. Tatiana. Naya. Kazandu. Trina. Trina Small. Jean. Some people, I'm sure. So if we recall, this is what's called functional notation. Instead of calling this y equals parentheses x minus 9 squared, we're calling.
Shania's here. I'm sorry, Miss Webner.
Yeah, I saw. I went, what I usually do is after I've taken attendances, I go to my participant list. Now, and I check if, because I usually see how many participants I have, and it somehow asked, so I did see that you were here, Shania. Thank you. All right, so we're trying to figure out what f of 4 is, which means what we're looking for is when we replace the x with 4 in this expression, what are we going to get? In other words, f of 4 means the parentheses, instead of the x, I'm putting a 4 minus 9 squared. Now, this is not a hard problem to work out. We could do it using regular, just figure it out. I'm going to tell you how to do it with your calculator as well, because you really want to get used to using your calculator. Okay, obviously this is not so hard. When you're figuring something out, you always work inside your parentheses first. So 4 minus 9 will give you -5. And there's a square on the outside. The square on the outside means multiply it by itself. So it means do -5 times -5, which gives you +25. And your answer would have been 25. All it means we're going to use this functional notation several times during the term, and it's just another way of saying, figure this out, where I know now I'm filling in, instead of filling in the x, just having an x in it, fill it in with whatever number this is. If you wanted to do it on your calculator, this is what you would have done. You would press your parentheses button, the open parentheses button, because there is one. Okay, so here's your first button that you press. You then put in 4. Then you press the minus button. Maybe I should just do all of these buttons and squares. Now this is the subtraction button, which is right underneath the plus button. There's a plus, there's a times, a plus, a minus, a division sign. They're usually on the right hand column of the calculator. You then put in your 9, and then you press your close parentheses button. And then you press, there should be a button that says x squared. Usually located in the left-hand column, the furthest left-hand column of it. Not all calculators have it in the same place. But when you see this X squared button, what it's going to do is take whatever you put in on your screen and square it. Of course, if you then press equal or enter, your answer will come out to be 25. If you have a calculator, I think you should try it just to make sure you know how to use these buttons. Again, if anybody has a calculator, they're not sure if it's a good calculator, you can show it to me. Few people have. And if you have a calculator that you've tried using and there are things you don't know how to do, just log on and tell me or send me an email. You want to meet with me personally, and I will describe once I look at your calculator, I'll tell you how to use it. But it sort of has to be on an individual basis because every calculator is slightly different. Okay, we have now completed chapter 2. We are now going to be talking about chapter 3. Now, what is chapter 3 about? Chapter 3 is what's called systems of equations. Okay, let me erase this. Suppose I were to give you okay, suppose I gave you these two equations. I have 3x minus 2y equals 6. And I have another equation, that's equation number 1, x minus y equals 1. So I have, call this equation A and equation B. In the same problem, I'm dealing with these are linear equations. Both of these will give us lines on our graph because there are no x squareds, there's no y squareds. It's a first degree or linear equation. Now we know, what did we do when I first gave you an equation, a linear equation? We learned how to graph it. And we could graph this. But of course, you can't really solve a linear equation that has an x and a y. You can get y equals something times x. You can get it in the y equals mx plus b form. But there's not just one number that works because there are two variables. But what if I have two equations, two linear equations in the same problem? That is called a system of equations. And a system of equations, and you could have more than two equations. If you have, you always have in a system of equations as many variables as you have equations. So in this case, we have two variables. We have an x and a y. So therefore, we need two equations. we don't do this in this class, but you might in a more advanced class do a system of equations that would have three variables, not just an x and a y, but an x, a y, and a z. But then you would need three equations. Again, we don't have to worry about that in this course. Okay. Let's think what it might mean when they use the term solve the system of equations. So before I do this particular problem, I'm just going to talk about it in general. We have two equations, two linear equations. Obviously, they represent lines. What could happen when we have two lines in the same equation, the same problem? Well, one thing that could happen, here's the first situation. I draw my lines, and I draw the first one comes out like this, and the second one, let's say, comes out like this, and the two lines cross where it is intersect. The two lines cross. How many points could they cross in? Obviously, only one line. They're never going to come around and recross. These are straight lines. So the most they could do is cross in two lines. The point where they meet is called the solution of the solution of the system of equations. So when I'm looking for the solution of a system of equations, I'm looking for the point where the two lines cross. And of course, that point is going to have an x and a y value. So we're going to look for the x and the y value that works in both equations, which means that the point is on both lines. We're looking for the point of intersection. That's the most common type of situation. This is what's called a consistent system of equations. What's another situation that could arise? You have two equations that you draw. And you draw the lines of the two equations, but what happens are the two lines turn out to be parallel. We would even know ahead of time if the lines were parallel because they have the same slope. Well, remember, we said when we're looking for the solution of a system of equations, we're looking for where the two lines intersect. Obviously, here, there is no solution because the two lines are parallel. They're never going to meet. There's no solution. We could also say, remember we called this a consistent system of equations when we got a single line. This is called an inconsistent system because it has no solution. You can't solve, in other words, find the point where the two lines meet if they're never going to meet. There is a third situation. You go to draw your two lines, and you draw your first line. And then when you go to draw your second line, it turns out to be right on top of that first line. The two lines actually are the same line. One line right on top of the other. That's what's called a dependent system of equations. the two equations, the two lines are not independent of the other. They're not different lines. They're actually the same line. In terms of solutions, there's an infinite number of solutions. Infinite means endless, infinite solutions. Any point on the line. There are an infinite number of points on a line. Any point on either one of those lines are going to be the same. So there's an infinite number of solutions in a dependent system of equations. Now, what we're going to do is, whenever we want to solve a system of equations, we're going to go under the assumption that we have a consistent system of equations, and we're going to try and graph it and solve it that way. We're going to learn how to solve it graphically by drawing a picture. And if you want to do a good job on this, you really have to do it on graph paper, because if you're slightly off, your answers are not going to be correct. If you do it on graph paper where you can count the boxes easily, then you will get a very good graph and answer. Because the graphing system is not always so reliable, especially if you don't have graph paper, I'm going to show you also how to do it algebraically, just by working with the equations. But the first thing we want to do is do an example using solving graphically. I'm going to take this system of equations. Remember, with a system of equations where you have two variables, an x and a y, you're going to need two equations. And we have them. We have 3x minus 2y equals 6 as one equation. We have x minus y equals 1 as our second equation. Okay, so in order to do that, I'm going to obviously have to, I don't know whether it's consistent, inconsistent, or dependent. I'm assuming it's inconsistent. It is consistent, and I'm going to go ahead and work on it as if it is a consistent system of equations. If I run into a problem, and we'll see the type of problems we might run into, then we will have to make a different decision. Now remember, in this, we're not writing the equations. I'm giving you what the equations are, and you're solving it. So let's take, what we do is we separately, but on the same axes, the same x and y, we graph each line. And in order to graph it, we have to put it in the y equals mx plus b form. 3x minus 2y equals 6. So I'm first going to solve this for y. I'm going to get the y's all by itself. So minus 3x from both sides, just like we've done before. This gives us negative 2y equals, remember, these are not like terms, so I leave them separately, negative 3x plus 6. And then I divide everything by the coefficient of the y. The number in front of the y is negative 2. We're going to divide every term by negative 2. Not just the negative 3x, but the 6 as well. So what do we end up with? We get y equals, well, negative, this cancels out. Negative 3 divided by negative 2. Well, we can't really reduce it, but the negative over the negative, we could change it to a positive. And 6 divided by negative 2 is negative 3. So now I have my equation, my original equation A, in the y equals mx plus b form. So I can tell you what its slope is, and I can tell you what its y intercept is. This is going back to the very first thing when we started chapter 2, how to draw the line. The slope is 3/2. The y-intercept is -3. Remember, the number in front of the x is the slope. The standalone number, the constant, is the y-intercept. So if here is my graph, if I want to draw that line, I have to always start at the y-intercept. So I'm going to start at -3 on the y. This is my y-intercept is -3. The slope is telling us that it's 3/2, which means we're going to be using rise over run. We're going to start from this point, -3, and we will rise 3, which means go up 3, and run 2. Go 2 to the right. I could do this again. Rise 3, 1, 2, 3, 1, 2. Or I could have gone down 3, but then I have to go 2 to the left. I like to do a bunch of these points. You really only have to do 2 if you have good graph paper, but I don't, so here's my line. And this keeps going on and on in either direction. This is line A. We have gotten the graph of line A. Okay, now let's look at line B. Line B, forget about A now. I'm working on B. Is x minus y equals 1. Again, I have to put this in the y equals mx plus b form in order to get in order to get
from flushing and why.
in order to get the example in y equals mx plus b form. So therefore, we could graph this second line. So the first thing I'm going to do is subtract x from both sides, because I want the y alone, which will give me -y equals -x plus 1. You always have to be very careful with those signs. And I don't want to have -y. I want y, which means I have to divide by -1. -y means really the coefficient is -1. So I'm going to divide every term by -1, which will then give me, let me write it over here. Y equals, well, a negative divided by negative is positive, so it's a positive x, and 1 divided by -1 minus 1. So what does this mean? It means that it's now in the y equals mx plus b form because it's y equals. The slope is the coefficient of the x. Now there's no number in front of the x, so it's understood to be 1, which I'm going to write as 1/1 because we want this slope to be written as a fraction, so it's easy to use it to graph. The b, the y-intercept, is -1. So now I can draw line B. How do I do line B? Well, my starting point again is always the B, the y-intercept. Y-intercept in this case is -1. So here's the starting point on that line. the slope we said was 1, which means the rise is 1 and the run is 1. So from here, I'll go up 1 over 1, up 1 over 1, up 1 over 1. I don't know. I think I've got it. Up 1 over 1. Okay, let's see. It looks to me, if I look at this point, now here's where I'm going to run into it. This is what my line, this is what my second line looks like. And you see where if I would have had graph paper, this would have been a bigger help. These two lines obviously do meet. They meet right over here. If I had really good graph paper, I could see exactly the box on which it's crossing. Here, it's a little bit hard to see, but it looks to me like it's crossing where the X is 4. Look at it, I go 1, 2, 3, 4, and up 3, 1, 2, 3. So I think this is the point for 3. The point where they are meeting, the solution to this system is 4, 3. You could have also written it like this: the X equals 4 and the Y equals 3. You could either write it as a ordered pair, because that will mean that the first number is the X and the second number is the Y, or you could write separately what you think the X and the Y is equal to. But this is how we would solve a system of equations. Notice this was a consistent system of equations, and what you have to do when you're solving a system of equations is find the point that the two lines have in common. That is called the solution of the system of equations. You could even check. I'm going to show you how we check. How do we check our answer? Not by going to the graph, but if we want to check, and I'm going to do it right over here. Where's my check? What you have to do is take the answer and put it into each equation and see if it works. So if we want to check equation A, we're going to take the X and replace it with 4, and we're going to take the Y and replace it with 3. So it's going to be 3 times 4 minus 2 times 3 equals 6. Let's see if this is true. 3 times 4 is 12. 2 times 3 is 6. So it's 12 minus 6 equals 6, which is a true statement. So this answer works in our first equation. In order for it to be a solution for the system equation, it has to work not only in one equation, it has to work in both equations. So I have to check what 2 as well. We're again going to take the X and replace it with 4 and the Y with 3. Notice what I get. I get 4 minus 3 equals 1, which is obviously a true statement. In order to be a solution to the system equation, it has to work in both equations. It checks in both equations. Therefore, this is our solution. Quite a bit of work. I'm going to now give
A
you
lot of work.
a lot of work, right? Okay, do you want to try one on your own? You ready to try one on your own, or do you want me to show you a simpler method? Question.
You could show us a simpler method and then we try it that way.
Okay. So this method is the method that you have to use. Okay, well, I have to show you the simple method and then you can do one on your own. And I'm gonna erase this problem. I'm gonna do one that's in the simpler method, but I'm gonna start with a simpler problem. Again, unless you're told specifically that you must solve it graphically, or you're looking at a problem and you're asked to put it on a graph, which there will be those type of questions on Delta Math, you're going to have to do with this method. But if you're just told to solve it and you're not specified any method, then we can do it by a more simple, more accurate, and a more efficient method by not going to the graph at all, without drawing it. And there are two ways that can be done. So let me give you another question where I'll show you this new method. Okay. This first method that we're going to be learning, first algebraic method, the one that doesn't involve graphing, is called the elimination method. And you'll see in a minute why we use the term elimination. Let's say I gave you these two equations. The first equation is x plus y equals 2. The second equation is x minus y equals 4. Okay, again, the numbers look simpler here, and that was intentional. I want to give a simple example. But again, it's a system of equations, and again, you're told to solve the system of equations. And nothing is mentioned to us about graphing. We could have done it by graphing each line and drawing each line and seeing where they cross and hopefully getting the right answer. Again, when you're doing it on the graph, if you're not very accurate, even if you do all the work correct, if your graph is not drawn perfectly, you might get the wrong answer. You might be slightly off. But this method is, if you do it correctly, for sure will give you the right answer. I'm going to take these two equations, which are what we call in standard format, where you have the x's first, then the y's, then the equal sign, then the numbers. That's the standard format for a system of equations or for a linear equation. Notice it's not the y equals mx plus b form. We didn't get y equals. We could have done that, but we're not. We're leaving it in the standard format of first the x's, then the y's, then the equal signs, then the numbers. Notice how everything lines up. And what we're going to do with these two equations is we're going to add the two equations to each other. And that makes sense that we could do it because we're starting out with things that are equal. So if we add equal things, we're going to get equal things. So adding these two equations, and they're easy to add because we have it set up so that the like terms are under each other. We're gonna do x plus x, which of course will give me 2x, because this means 1x plus 1x. Then the next thing I have is a plus 1y with a negative 1y. And the y's cancel out, because y minus y is 0. I don't have to put in 0, it's just not there. Notice the y has been eliminated. And then we add the 2 and the 4, and we get 6. Now, the object of this is to figure out both the x and the y separately. Notice we don't have any y in this equation. When we have x's and y's in the same equation, we can't solve it because they're two variables. We can only solve an equation that has one variable. But that's what we did when we added the two equations. We eliminated one of the variables. This is a really easy equation to solve. Just divide both sides by 2. And you get that x equals 3. I know in this system of equations, the answer for the x has to be 3. So number one, I'm getting an answer for x, which means it's a consistent system because I'm getting an answer. And number two, I didn't have to do any graphing. The only thing is that it only gave me the x. And I need, as a solution for a system of equations, I need both x and y. So how am I going to figure out what y is? So what we do is we take one of the original equations. I'll take the first one, x plus y equals 2. And replace, I now know what the x is, so I can replace the x with 3. That'll give me 3 plus y equals 2. And solve that equation, and it gives me y equals -1. So now I have my system solved. I know that x equals 3 and y equals -1. I could have written it as 3, -1. Notice I can check the answers like we did before. I'm just going to do it by talking it without actually writing it. 3 plus -1 does give us 2. And 3 minus -1. Remember, when you have a minus of -1, it becomes a +1. So that becomes 3 plus 1 is 4. It does work in both equations. I did the correct work. I've gotten the solution to the system of equations. And notice I didn't even have to draw a graph. And look at how efficient it was. Look how quickly I did it. Didn't have all the other question that I did. I had to work on the whole board, and it was a big mess. What did I find? I found, without drawing it, but I found this is a line and this is a line. If I would draw those two lines, the place that they would cross, the point of intersection would be the point 3, -1. And again, it's called the solution to the system of equations by giving both the x and the y. Okay. Now I'm going to give you one to try on your own. And you could do this method. Here's the question I want you to do. This is x plus y equals 3x minus y equals 1. Okay, and again, if you really want to do it, you could do it by the graphing method, but I think the more efficient method is to use this elimination method. Again, the only time you really have to do the graphing method is if they ask you to graph it. Otherwise, you can do it using this method of elimination. Okay? Then if you didn't answer, you can put it on the chat. I'm leaving this on the board so you get an idea of how to do it. Okay, give you about 2 more minutes to try this. Should we work on it together now? Okay. Great, I see, Cassandra, you. Okay, well, let's see, we're getting now a couple of answers, let's see how this works, okay. So we're over here. And what we said, if we're using this elimination method, notice everything is set up. Sometimes we're gonna get cases where it's not set up properly, but now it's set up. X's, Y equals numbers, everything lined up. So I just add them. X plus X is 2X plus Y and negative Y. That cancels out because a +1 and a -1 is 0. So that just cancels out. And 3 plus 2, when I add it, gives me 4. Well, now I only have x's here, so I can divide by 2 to find out the value of x. And I get x equals 2. And then I could go back to one of the original equations, it doesn't matter which one I use, but I always tend to use the first one, and replace the x with 2. So I have 2 plus y equals 3. And I'm going to subtract 2 from both sides to get the y alone. That gives me y equals 1. And yes, Kazandu, you were totally right. You got x equals 2 and y equals 1. Okay, don't forget, when you got 2x equals 4, you had to divide it by 2, Ariana, to get it below. Again, that's all I have to do. My solution is 2, 1. If I want, I could check, but if you don't have time, you don't have to check. This is the correct answer. And I want to just go one step further with this. Let's go to this problem. And let me take an example that looks like this. Two x minus y equals 6 is my first equation. And my second equation in the system of equations is x plus 3y equals 3. And again, I see I have a system of equations, and they're again written in the standard format. The x's are lining up, the y's are lining up, the equals are lining up, the numbers are lining up. So we have this system of equations. So if I do what I did before and I add the equations down, I'll get 2x plus 1x. Remember, x means 1x. And that'll give me 3x. And this will be a negative 1y plus 3y, and negative 1 plus 3 will give me plus 2y equals 6 plus 3, which is 9. And why am I not happy with this? Because before, when I added the equations to down, it eliminated one of the unknowns. It eliminated, sometimes it eliminates the x, sometimes it eliminates the y. In this case, it eliminated the y. And we only had an equation that had only one variable. But here, when I added the equations, I didn't eliminate anything. So this didn't work. This was not a good system. So what should I do? So I think, what will make a variable be eliminated? What caused it to be eliminated? Well, that's when I add them, I get 0. And the only time when I get 0 when I add is when I have the exact same number, except one is positive and one is negative. In other words, if I add 6x plus negative 6x, that'll give me 0. If I add negative 2y plus 2y, that'll give me 0. As long as the coefficients are the same number, but one is positive and one is negative, then I'm going to be able to eliminate a variable. If I don't, and that's exactly what I had here. Here I had a plus 1y with a negative 1y. I don't have that here because here I have a 2 coefficient with a 1, and this is a -1 with a 3. Neither the x nor the y were going to be eliminated. So let's say I decide I want to eliminate the y's. I want to do something to eliminate the y's. So I think about it. This has a coefficient of a -1. This has a coefficient of 3. I need them to get to have the same coefficients. So what I'm going to do is I'm going to multiply each equation by the opposite coefficient. In other words, remember, it's the y's that I want to, and it means, and I'm just looking at the numbers. I'm not looking at the plus or minus, just the numbers. This has a 1. It's understood to be a 1 here. This has a 3. I'll multiply the top equation by the 3 and the bottom equation by the 1. I multiply them by their opposite coefficients. The top one I multiply by the bottom coefficient, the bottom one by the top coefficient. And remember, I said I first only take positive numbers, but then I think I need to end up with one being positive and one being negative. In this case, I already have it. This is negative and this is positive. So I only want to use the positive numbers. If both were positive or both were negative, I would have to do something with the signs, but I don't in this case. All I have to do is multiply the top equation by +3 and the bottom equation by +1, and then the y's will have the exact same coefficients. Remember, when you're multiplying, you have to multiply the whole equation through because you don't want to change the equation. And multiplying everything in the equation by the same number keeps it the same. So the top equation being multiplied by 3 will give me 3 times 2x, which is 6x. 3 times -1y is -3y. And 3 times 6 is 18. Notice I multiplied everything on the top equation by 3. The bottom equation, I'm multiplying everything by 1 because I'm multiplying by the opposite coefficient, and this coefficient was 1. Notice when you multiply by 1, you're not changing anything. So this stays x plus 3y equals 3. By the way, sometimes there are other methods that can be used. I'm going to consistently use this method of elimination of multiplying them with their opposite coefficients. Now let's see what happens when we add. So when I add 6x plus x, I get 7x. When I add -3y plus 3y, it gets eliminated. Remember, my focus was to eliminate the y's. That's why I got the y's to have the same coefficient with opposite signs. It's a -3y plus 3y, that's 0, it's eliminated. And then I do 18 plus 3 and it gives me 21. And now I can go further because I only have an x. I can divide both sides by 7 and that'll give me x equals 3. I solved this for the x. Notice it involved a second step. It wasn't enough just to add the equations. I first had to multiply the equations to make sure they had the same coefficients but opposite signs. Once I have what my x is, I can go to either one of my first equations, go back to the original, and replace the x with 3. So in this first equation, if I use that, it'll be 2 times 3 minus y equals 6. 2 times 3, I'm going over here. So 2 times 3 gives me 6. 6 minus y equals 6. I can now find what the y is by subtracting 6 from both sides. I get negative y equals 0. And of course, I would have to divide by -1 to get what y is. And that 0 divided by anything is 0. So my solution to this equation is x is 3, y is 0. Notice that works in the second equation as well, because 3 times plus 3 times 0 is 3 plus 0, which is 3. So we found the solution again by the elimination method, but I had to do an extra step. Okay, I have to leave a little bit early today, so I'm going to stop now. Does anybody have any questions they want to ask me? Make sure to check if there are any, if you're up to date with your homeworks on Delta Math. There are a couple people who have not done anything on Delta Math. You must be in touch with me and let me know what's the problem. If you're not doing the homeworks and you're not doing the quizzes on Delta Math, you're going to lose 40% of the credit of this class, because that's where it comes from. 40% of your credit, 35% is from class work, class quizzes, tests. The rest is from the final and the midterm. Okay. Any questions? And then I'm going to end the session now. Don't forget, we do not meet on Monday. We meet next Wednesday. We also make Thursday. The Thursday is to make up for the Monday, and we meet next Friday. Okay. And Patrice, I'll be in touch with you next week.
Got it.
Okay. Have a great weekend, everybody.
You too,
You too.
Professor.
Thank you.
Bye.
Bye-bye.